Welcome to all. Class number 60. See, now this will be almost the last question in the series of UDL with point loads. Then almost last. After this question, I'll just consider one more question. See, two places UDL with point loads. Last time I considered a question with different UDL on either side. Now, two UDLs and 2-3 point loads. One question now, one more question after this one. Then I'll go to new part. Maybe uniformly varying load or couple after that class. Question here, instead of words, sketch given. See, this is the beam. For this you have to draw SFD and BMD. Or if you want words, I will tell in the words. A beam of length 10 meter is loaded by UDL of 30 kN per meter for 3 meter from left end and another UDL of 20 kN per meter for 4 meter length starting at 4 meter from left end. Then 3 point loads 100 kN at right end of the first UDL, 80 kN at right end of the second UDL and 60 kN at 1 meter from right end, or 100 kN at 3 meter, 80 kN at 7 meter, not 7, 8 meter and 60 kN either 9 from left end or 1 from right end. Draw SFD BMD. Solution. First, support reaction calculation. AB. Okay. So, correctly take moment about A, clockwise positive, not required right every time. It is understood. See, minus VB into 10. Because this is moment calculation, sign convention based on direction clockwise. Plus UDL. 30 into 3 is the total load due to UDL. 30, actually this I don't have to tell. It is told so many times. So I will not waste time now onwards for such a repetitive expressions. So finger here only. 30 into 3 is the total load into 3 by 2 plus 100 into 3, 20 into 4 is the total UDL into 3 plus 1, 4 plus another half of 4 plus 80 into 3 plus 1 plus 4 is 8 and lastly 60 into 9 equal to 0. You get the value of VB. Sigma V0 plus VA plus VB minus 30 into 3, only loads now, minus 100, minus 20 into 4, minus 80, minus 60 equal to 0. Substitute VB, get the value of VA. We are ready for SFD and BMD. Now, I will go for SFD BMD for this one. We are ready for shearing force diagram. Beam is already written here neatly, preparing for SFD. That is all preparations you have to make first. Okay, I will project the points. I think slightly it has come out of scale for 3 and 4. No problem. One more point here. Okay. See. This time we will do one thing. For a change, first we will draw shear force diagram. For a change, shear force diagram, all values are in kilonewton, left up, right down, positive. See. For a change today, what? We will start first. We will not do calculation. Go up by 200.5. Then, see, calculator should show 200.5 now. From A to C, UDL acting down. I think I should stop this one now. Whenever you draw shearing force diagram from left to right side, remember, if it is upward force, then it will be positive. If it is downward, it will be negative here also. And you go with the load. So when you go with the load, down 30 into 3, subtract 30 into 3, you will get 110.5, almost half. Okay. This is 110.5. You can also do one thing. Simultaneously observe here. See, then come down by 100. At the same point, suddenly down. Small value. How much? 10.5. Okay. Then C to D, there is no load, go parallel to baseline. From D to E, gradually come down by 20 into 4. So minus 20 into 4. 30 point. See, my calculator is still showing positive because when I came down by 100, I forgot to operate the calculator. So therefore, you have to operate 110.5 minus 100 will give you 10.5. Now minus 20 into 4 will give 69.5 here. See, somewhere here. And remember, it is 69.5, it is 10.5. It will cross the baseline quite near to this point. That is very important observation. But it is 110.5. So, okay, 10.5, 10, 20, 30, 40. Okay, done. No corrections further. This is 69.5. Slightly out of K. I already told you. No problem. Down by 80. 80. See, I should come more now. Okay. Minus 80. Because of space problem, I am slightly changing the not scale, little out of scale. Minus 149.5. From E to F, no load, go parallel to baseline. Come down by 60. Come down by 60. So, minus 60 is 209.5. 209.5. No load, go back by 209.5. Shear force diagram will close. Plus, minus. Now, this point is A, B, C, D, E, F. A new point I will call G. Let it be X from here. If that is X, this will be 4 minus X. We will show calculation there, then we will come back and enter the answer. I will get it now only. 0.525 will come. X will come 0.525 meter. Calculated value. Then this will come 4 minus that one. 3.475 meter. All calculated value. Okay, I will round up that much only. 4 minus X will come 3.475. This is the shearing force diagram. Now, briefly, shear force calculation. Sometime it is possible. Someone will comment. What is happening? You do the calculation first, then draw the diagram. This is reverse way, not reverse way. I told you, we show calculation only from academic purpose or to benefit the students, those who are studying for examination. Those who are learning the subject, directly they can draw the diagram. Even students also, after showing the calculation, directly they can draw the diagram. Okay, now, just to complete the question, start from left side, we will go with the shear force calculation, considering from left side only, slowly will come this way. Okay, today I will tell last time. You start from there. Since you start the calculation from left side, our convention is what? Left up positive. So when you come from that side, any upward force will be positive shear, any downward force will be negative shear. That's all. So I don't have to keep on telling this one every class. I will tell later once in a while. Okay, start. At A, come slightly right side or technically slightly inside. Someone who is new to the class, he will tell, why should I come slightly inside? Class number 60. Go through all the classes. Everything is thoroughly explained, was thoroughly explained. So, in between you come and suddenly want to understand, it is your capacity. If you got that much capacity, well and good. But when I take the class, I see that everything is systematically explained. So, everything earlier told repeatedly, how many times also I don't remember. So, go through. If you want to learn the subject, to master it, these 60 classes, average half an hour, say 30 minutes, 30 hours. It is not a big thing. It is a very small time to get the mastery on SFD BMD. Okay, start. Shear force at A, come slightly inside, plus 200.5. Come to C. Now I am not writing like earlier. Note, there is a point load there, shear force you have to do twice, That all I am not telling now because told so many times. Those who want right. See, C point load is there, E point load, F point load. So all those 3 points, you have to do shear force calculation twice. Okay, start. Shear force at C, just to left of C. See, again, what you have to do? Whatever you got previous shear force, that is after slightly right of A, up between A and C, there is UDL of 30 kN per meter. So, subtract 30 into 3, you get shear force just to left of C. Then, shear force at C, just to right of C is whatever you got just to left of C, subtract that downward load. If the load is down, subtract. If the load is up, add. But that is only if you start from left side. Not from right side. If you do calculation from right side, then left side. See, when I look here, this hand is right side. But I will talk for your benefit. So, left side if you start, you should do that way. If you do from right side, you have to go reverse. Means what? If the load is up, you have to take negative. If the load is down, you have to take positive. I told last time, shear up, downward load, shear force diagram drops, upward load, shear force diagram jumps is not a correct statement. It is only valid when you come from left to right. So don't go for such crude methods. Over. Minus 100, 10.5. Then shear force at D, only one calculation. Previous value, 10.5. Between C and D, nothing is there. That's all. Leave it. Shear force at E, just to left of E, 10.5 minus 20 into 4 will come minus 69.5. Just to right of E, minus 69.5 minus 80 minus 149.5. Shear force at F, left side, minus 149.5. Between E and F, no load is there. That's all. Just to right of F is minus 149.5 minus 60 minus 209.5. Lastly, shear force at B slightly inside, minus 209.5. That's all because no load in between. Check for you. Just look right side. If you look right side, it is upward of 209.5. Right up is negative, so perfectly tally. Over. Next, some statement you have to write. Now you require variation. A to C UDL, D to E UDL. So between A and C and D and E, linear variation. Whereas between C and D, E and F and B, not between, for that portion, constant. I written here. Constant for that portion. Or constant, okay, between also will do, or for also will do. Your choice. English problem. Okay, then draw the diagram. Okay, now come and draw the diagram. Observe the diagram. Yes, shearing force diagram crosses baseline at an unknown point G. Get the value of X. You have to get the value of X. 0.525 meter. I'll put a question mark here. Question mark means not wrong. In my class, if I write question mark, it means you have to get the value. See, option 1. Shear force at G equal to, here we got shear force of 10.5 minus 20 into X equal to 0. Second option, third option, I told so many times, you carry out that one, get the value of X. Come back and enter. Ready for shearing force, ready for bending moment diagram. Why? SFD over. Now go for bending moment diagram. I will show that, I will do one thing now. Now onwards, if anything is repetitive or same concept as earlier, calculations I will write before starting what? Recording. Because if anything new, I will write in front of you with full explanation. Anything mechanically means what? As usual, there is no much changes. But I will explain, I will prepare, write it earlier and then start. So that you can save the time, unnecessary time is not wasted. Okay. Now, we will go for bending moment diagram. All calculations I have shown, I will explain. BM at A, 0. BM at C, look this side. Plus 200.5 into 3 minus 30 into 3 into 3 by 2. BM at D, plus 200.5 into 4. Why 4? 1 plus 3, 4. Minus 30 into 3 is the total load into 1 plus half of 3 up to center. Minus 100 into 1. It will come. Answer is there. BM at E. Better look this side. Plus 209.5 into 2 minus 60 into 1. Then BM at F plus 209.5 into 1. Okay, now also you require BM at the point G where shear force is 0. You can look any one side. Okay, I will do one thing now. I will consider left side. Then see somewhere here G. Remember G point is here. From here to here is 0.525. We want BM at a point from D at 0.525. Therefore 200.5 positive into 0.525 plus 1 plus 3, that is 4.525, minus 30 into 3 is the total load due to UDL into 0.525 plus 1 plus 3 by 2. I written there. Or I wrote 1.525 plus 3 by 2 minus 100 into 0.525 plus 1, that is 1.525, minus moment of the UDL only for 0.525 about this point. So 20 into 0.525 into 0.525 by 2, I got the answer. Okay, next. Or just for see right here, only for understanding purpose or better bit, find BM here, look this side, no problem. Plus 209.5 into 3.475 plus another 2, that is 5.475, minus 60 into 3.475 and 1 total 4.475, minus 80 into 3.475, minus 20 into 3.475 into 3.475 by 2, and not bother to calculate. Still, I am not check the answer by my own shortcut method. I will check it now. That is, I don't have to locate this point. $479.75625. Yes, correct. Now, variation. A to C is parabola. See, ending point slope is 110.5 or okay, parabola. Then C to D is straight line, linear. But remember, very small shear force. You can see here, slope is very small. Slight change in the bending moment, slightly increasing. Then start from here. B to F is linear. E to F also is linear. Oh, now see what happened is it looks like same line. This is 200.5. This is 359. It is because of out of scale. Okay, 1 minute. And also two reasons. Linearly 1 and 1. See, 1 meter here means somewhere here and 1 meter here. 359 by 2 is around how much? 200 will come. See, now perfect it will match. See now, that line has got higher slope. This line has got lesser slope because high shear force. That region high shear force. This portion lesser shear force. You can make out. If you draw to scale, it will correctly come. It becomes slightly tilted. See, over. Then, now lastly, from D to E, a single parabola we should see, and slope is, see, at this point, shear force is 10.5. Whatever is slope for this line, same line slope. So tangential it will go, reach peak value and then drop back. And this side, shear force is 69.5. If you draw a tangent here, see, actually, it will go little, where is it? 479.5 is very nearby. Okay. Tangent, no, it looks like more slope now. I'll manage. This slope is, this side slope is 149. This side slope should come lesser. Okay. See, difficult because, but I am telling it here. Okay, now slope is lesser. I managed. Remember, this is single curve. One parabola will come. Okay. This is the peak value 479.75625 over. This will complete our question. Thoroughly practice, get more and more understanding. Now, next class 61, I will take up the last problem of combination of UDL and point load. What I will do is, I will put UDL this side and this side partial, and then in between UDL, I will put some point load and make a little bigger question so that very thorough grip will come. But I will do one thing. SFD, I will see that it will cross the baseline at a known point. So that is, you don't have to locate this point. That is, you worry in the next class. Okay. Now, next class, class 61, we will meet again to continue and consider the last question of simply support beam with the UDL and point load combination. Okay. Thank you.